Now we go to the second paradox for the ordinal approach, the Allais paradox for decision-making under risk. In many respects, it's the most central paradox in the field. Let's look into it. So Allais 53 published it, and many experiments confirmed what he conjectured and already showed. It's a violation of expected utility. And the preference in the example below, I will indicate always majority preference and ask what you think about it also. They will violate independence condition, so expected utility. Capital M will abbreviate €1,000,000. Imagine there's a choice. You can get 10 million for sure, or you can get a probability distribution, a lottery, giving you 40 million with 80% probability, but 0 with 20% probability. Question, what do you prefer? You can stop the video, make up your mind, and then continue listening. Anyway, I show now what the majority preference is. Most people prefer the sure 10 million rather than the gamble. Of course, this violates expected value, that's obvious. Second choice is given below. Imagine on the left is your option that you can choose 0.25 probability of 10 million, nothing otherwise. The other option on the right gives you a 0.20 probability at 40 million, nothing otherwise. What would you prefer, left or right? Again, you can pause the video, make up your mind, and I will next show what the majority preference in this situation is. The majority preference is that most people now prefer the right option rather than the left option. These both preferences seem quite plausible, but I will claim they are irrational, because that's my opinion. But surely they violate expected utility and violate the independence axiom. Now I'm going to discuss a bit more why they may not be rational. Well, not everybody agrees, but it's my opinion we're discussing here. I put up an intermediate middle choice situation to clarify some points. The left option in the intermediate choice situation is the same as what we saw below. 25 probability of 10 million, nothing otherwise. The right option is a two-stage gamble. 0.75% it goes down, you get nothing. 0.25% it goes up, and with then, when you're there, with 0.8 probability of 40 million or nothing otherwise. And now I ask you in this third situation, what is your preference? You can pause the video and then listen up again. So I'm going to discuss all kinds of preferences here. First, imagine that you put here strict preference for the left option. Well, I'm saying that cannot really be. That's so much that is really beyond debate. And the reason is, if imagine here you have the preference that I wrote here, you prefer left to right. I compare it with the lower situation. The point is the two situations are the same. Because if you look, of course, these two are the same. But if you look a bit carefully, you see that these two are also the same. So I put here identity. Because if here you do calculation, this means here with 0.25 times 0.8 is 0.2 probability. You get 40 million, you get nothing otherwise. This is the same probability distribution as that. So they are the same things, same probability, same outcome, everything the same, just probability calculus. So I think these two choice situations are the same. So the preference for left here cannot be, I think. Therefore, let us look at the preference for right. That takes a bit more of debate. First of all, that is violating independence. So we're going to assume for quite a while to come that you prefer your right to left, but here you prefer left to right. So I'm discussing majority preferences. In that case, I say independence is violated because if you look a bit carefully, you see these two prospects, lotteries, are obtained from those two in the same mixing way. 0.75 mixture weight probability is assigned to the lottery that with certainty gives 0. 0.25 probability weight is given to that one or that one. That's how this gamble results from that gamble. And therefore, if here you prefer going right, so that, so the lower preference here, so the opposite sign and this one, that cannot be, At least that is a violation of independence. Maybe a while back when I presented independence to you, you felt that it was looked like a rational condition, and I think it is. But here many people, even if they feel what I just said, they don't change their preference. They continue to say, no, I continue here to prefer right, and here I prefer left. I continue to violate independence. There are other things going on beyond independence, because of which I want to violate independence. So here we have on the one hand independence, which may be an argument that here you should choose left, but there are other arguments that you want to choose right. They are in conflict with each other. We have to think about it. So then what kind of arguments can people put up to still prefer right? You can maybe pause the video, make up your own mind. I will now discuss a few reasons that people put forward. One reason that people put forward is the emotion of regret. They say, if in the upper situation I had chosen right and I ended up with a zero outcome, then all my life I would blame myself. I had lost 10 million due to my mistake. I could not sleep anymore. I would blame myself. I would feel regret. I cannot have it. In the lowest situation, I don't feel that, because in the lowest situation, if I end up with zero, it can happen in both situations. So I don't feel like blaming myself so much. It could have happened anyhow, ending up with zero. So it need not be my own mistake necessarily. That's the regret emotion. Many people put that up as an argument. But I am going to argue it's not a rational argument. I think if here in this upper situation you chose right, you end up with zero, and you're blaming yourself for the rest of the life, you're just harming yourself for no good reason. I think you could have said, I did my best choice and I was unlucky, and not blame yourself. I think if in this outcome zero, you are more unhappy than in that or that outcome zero, you should not do that. You're harming yourself. It's sort of your moral duty to be as happy as you can be. Here you have the same future ahead as here, you can be equally happy. So this form of regret in this situation, I think, is irrational. Surely in general, regret is a very useful emotion in many situations, giving out good signals. But here in this situation, that regret that we now discuss is irrational for the reason that I just argued. So that I do not buy, although many people disagree with me, but that's my opinion. The second reason that people put forward why in this middle situation they choose still the right one, it is, they say, and they can compare it with the lower situation, that's the same. They say the probabilities are not very different here. 0.25 or 0.20, there's not a very big difference. The payoffs are very different. 40 million is much more than 10 million. Therefore, here and in the middle situation the same way, I go for the payoff and not for the probability. Well, that's also argument often put forward, but I think it is a misperception of numbers. Because if you look carefully, if you know how these numbers work, I think you can see that the proportions of probabilities are relevant in the upper situation as much as in the lower. I think here also you have the probability here is a quarter, 25% bigger than here, so to say. You know, a quarter of this is coming to it. That's a lot. So much less risk of ending up with zero. That's something to be taken very seriously. Therefore, I think the probabilities here, you should not say, make it easy on yourself, oh, they're about the same, I ignore them. You should realize that they are still quite different probabilities, especially given the stakes. So I think this is a misperception of probability. So I know this is not 100% clear what I say now, but still I disagree with that argument. Let me not try to explain myself more clearly, but go on to another argument. Also, sometimes papers say, here in the upper situation, I perceive certainty. If I go for left, I have certainty. In the middle and lower situation, there is no certainty. So then I behave differently. I have a special preference for certainty. That's why in the upper situation, I choose left, and in the other situations, I don't. And again, I cannot in 1 minute 100% convincingly cure you of this irrationality, if I may put it like that. But again, I think this idea, I should go for certainty is nice, is a misleading idea. In general, I think people are too risk averse. That's one thing that I learned from this paradox and much other work in behavioral economics. Too often, people miss chances in life because they are too afraid to risk any loss. This is, I think independence is the rational condition. So this argument of certainty, I don't buy it. I say, whether certainty here or not, it doesn't matter. This is in essence, this is quite the same choice as there. In the lower branch, if you compare these two, the lower branch, it doesn't matter what happens. In the upper branch, just you replace this thing, like if you have this preference really, then I think here you should also say, in the upper branch, it doesn't matter. In the lower branch, it doesn't matter, sorry. In the upper branch here, I can replace this by something else that is better. And if I think 10 million is better than here, then in this upper branch of sort of quasi-certainty, I should go for that just as much. But I know it's a bit complex. And even, I told you I have a field course, Risk and Rationality, which is specialized, goes deep. And decision on the risk is the main topic. This paradox and discussion about it are the main topic of that course. And I know after several meetings, still many students are not convinced and still in doubt. So these things that we discussed now are not very clear-cut. But also I think that here is where the behavioral approach is at its most interesting point. I think many of you can see there is a rationality in the independence condition. It has a convincing argument. But you also feel the other arguments like you discussed, and argue a bit against it, but many people feel it, that make you think the other way. So then you have arguments in yourself that are in conflict. And some must be wrong. There are some different instincts in you that are not coherent, that are not consistent. Then you have something to think about. Where is it wrong? And then you think about it. Maybe you can convince yourself, for instance, that certainty argument is a good one, and that therefore independence is not good in your view. But anyway, you have things to think about, things to improve and learn. That's the thing of behavioral economics that I like most. And this paradox brings it up quite a bit. Also, if people like me who say having these two choices is irrational, that's quite easy to see it's violating independence, but it's quite more difficult to say which of those two choices then is wrong. If you want, and that's of course the $1,000,000 question that we want and should answer. And here also the behavioral approach is doing a lot of work. The behavioral approach is studying many psychological phenomena going on, what drives people. And for instance, people are misperceiving probabilities. There's a lot of work showing that. The people do not sufficiently discriminate between probabilities in the middle region. So this argument that those two probabilities are similar, that is big to quite some extent because people are not sufficiently capable to perceive probabilities. And there are many studies in behavioral economics to show this. This is one of the ways to get better insight into what's going on here and which choice maybe should be changed. Also, that certainty effect, there's a lot of evidence and regret. These things are demonstrated in many situations. Then we can learn from those studies what is going on here. And then maybe some people, if they have these two choices, the upper choice is wrong. For others, the lower choice is wrong. That depends on all the biases going on there. And then again, behavioral economics is studying them a lot, but we have no time in this course. We can't discuss them very much more for this example, because we go to the next topics. Well, anyway, in the literature, when Allais published his paradox 52, 53, 54 in papers, first reaction of people was that they said, this may be true what Allais has, that may be a violation of expected utility, but that's just some weird extreme numbers happening in a laboratory, not very relevant for everyday decisions, or these extreme amounts of probabilities. So maybe this is a violation, but it's not important enough to pay attention to. That was one argument that people put forward much. And actually one of the contributions of Kahneman and Tversky was to show that this kind of thing also happened with practically relevant questions, not just with these extreme inputs. And people also would argue that subjects in this experiment doing this Allais paradox, because many experiments showed it, that they're just confused. If they can learn more, like in a market where you're punished for mistakes, then people will not make such mistakes. So there's some mistakes just of subjects, and in the market you don't see them really. That was a second reaction. Anyway, also that is not true, because many experiments have shown that these violations of rationality, whatever you call it, are very happening in many situations. Also in markets, they're very strong, can't be ignored. Well, Allais paradox, it is a problem. It was a problem, has always been a problem for the ordinal approach, known since the 50s. But again, if that were the only thing there was, that would not be enough to give up this rationality modeling and the ordinal approach. You can't throw away your old shoes before you have new ones. So, but it helped, and many more problems were to come. And then in the end, when there were so many problems, then people got ready for it. For decision under risk, that is where the Allais paradox is relevant, there are all kinds of other problems known. If, for example, there's the coexistence of gambling and insurance. Many people gamble in the lottery industry, but they also take insurances for their possessions and other things. So then one thing's just risk seeking, the other is just risk aversion. It's a bit, can be contradictory to each other. This has long time also been known as a paradox for the classical approach. And people didn't really know what to do about it. And for instance, but a few problems is not so, every model has few problems. For instance, Arrow, he wrote nicely about this situation, 1971, long ago. He said, I will not dwell on this point extensively, emulating rather the preacher who, expounding a subtle theological point to his congregation, frankly stated, brethren, here there is a great difficulty. Let us face it firmly and pass on. So you just have to go on with the best model that you know, and there are always problems. You have to be pragmatic in life. Another paradox came for maybe not risk but uncertainty by Ellsberg, which was as fundamental as Allais, that we presented next, that also contributed to the problem for decision-making under risk and uncertainty. His paradox concerned unknown probabilities, and is this thing that I am going to present next. This had deeper implication than the Allais paradox. It's very interesting to think much about it. Led to ambiguity theory, a big topic, a popular topic in decision theory today in the behavioral approach. Well, this course, we don't have much time to say much about it. But then let me next present the Ellsberg paradox, but that will be in the next recording.